Welcome everybody to our Soft Tree webinar series. My name is Jeremy Gonzalez and today I'm joined with Craig Spears, who will be presenting to you on GPS functionality as well as setting up your coordinate system. Just a few housekeeping items before we get started. All the participants are muted, and should you have any questions or comments, please engage us through the GoToWebinar panel. As with all of our webinars, this is being recorded and will be available on our YouTube page sometime after the presentation. We have a few upcoming webinars as well. The next one is on December 15th, which focuses on optimization and cost reduction. And in the new year, on January 12th, we will be presenting to you on SoftTree's OptiHaul graph. RoadEng 8, it's pretty much here. We've already started unrolling our trial process, so some of you might already be on RoadEng 8. Some of the new features include an enhanced user interface. We have a 64-bit version, which allows for more LiDAR data as well as a LiDAR thinning tool. You can now do multiple horizontal alignments. We have a new multi-plot report builder, field improvements in GPS integration, which we will be presenting on today, and many more. With GPS integration, on version 8, we wanted to make RoadEng feel more field-friendly. And with the availability of Windows 10 tablets like the Mesa, we've added new features such as touch screen gesturing, being able to connect to laser guns, and we've also integrated GPS into all of the modules so that RoadEng can be more field friendly. And now I will pass the presentation on to Craig.
Thanks, Jeremy. Good morning, everyone, or good afternoon, everyone. So, as Jeremy mentioned, one of our objectives in version 8 was to make it more field-friendly, and added, along those lines, we added some GPS capability in all of the modules. So, really, what are the reasons why we would want to have GPS in RoadEng? It's more of a design software. Well, first of all, you can now go out in the field, you can collect your notes, and you can turn on GPS signal and track where you are on the screen as you enter notes. You can also use the GPS to set what's called absolute coordinates while you're traversing. So pretty basic, but now you can do it directly in RoadEng. It's very useful. With the way things are going, a lot of people now are using LiDAR, particularly in the forest industry, resource industries, for initially designing roads and designing layouts in the office, and then going out in the field to ground truth those designs and layouts. And with the GPS capability and on a tablet, you can go out in the field, have your LiDAR available, have your design information available, and track where you are with the GPS functionality. So that part, I think, is pretty obvious. The final thing that may come of this is that now you will be able to go out after a road has been constructed, again on a tablet or a laptop in a pickup truck, and exactly track where you are on the cross sections and in the profile. Just as a tracking tool to keep close handle on where you plan to be and where you actually are when the road is constructed. And of course, you could use this tool at any time during the construction phase of the project. So it's just giving you really additional field response that you can tap into. So what kind of GPS devices do we support? The answer in general is we have, in this version, we are supporting mapping grade GPS, which is not strictly super accurate RTK or base station rover type GPS devices with post-processing. Mapping grade GPS is a little lower standard in terms of accuracy. And here's a list of the types of devices that we are providing for right now. The first one, Garmin USB, usually that's a recreational grade GPS. Lots of people have small handhelds or handheld GPS devices with Garmin, and you can take those out. The one that's probably most commonly used for this type of work is a NEMA serial device. And this could be a device from Trimble or one of the many manufacturers of mapping grade GPS. And it communicates with RoadEng over what's called a NEMA interface, which is a standard interface. And that can be done with either a direct serial cable or via a Bluetooth connection, which I'll talk a little bit more about in a second. The final interface that we support now is what's called Windows Location Services, and it's actually an emerging standard. It's supported by Microsoft, and it includes some GPSs, but it also includes things like network triangulation to determine location. So it's more of what's the word, general public type of interface. We may see in future that a higher standard surveying gear will be supported through this interface. We included it because it was easy to do, and it pretty much guarantees you some sort of location services wherever you are. So just a few words on setting up a Bluetooth connection, because this is probably one of the obstacles that people have to go through. People who've done this before realize it's not difficult, but if you're using a serial GPS, that is the NEMA format GPS, you may have an option on your GPS to talk to the computer without a cable. And in order to do that, you actually have to go into, I'll just show you here. I'll do it on my screen. I don't have a GPS device, but I have a laser device which I will try to connect to. So I would go into my Bluetooth connections, and it actually fires up here, and if my device is on, I should see in my list, which I'm not seeing, the laser device. Sorry, the Lasergun device. I'm not seeing it here, which is unfortunate. But anyway, what the concept is to pair the computer with the device, and when it does that, it will actually assign a COM port, and I'll talk a little bit more about that in a second. But you will get a COM port selection, and then when you're in RoadEng, you will actually have to configure that COM port. This is all laid out in our manual. The process of setting up a Bluetooth connection, maybe you've done it with other devices like your cell phone or other devices, but it's a standard configuration thing. I notice this is changing quite quickly, so I'm not sure why I'm not seeing my device, but I'm going to carry on. Yes, so sorry, back to my strategy here. Let's have a look at RoadEng. Let's have a look at connecting to a GPS device. And one of the things that you have to worry about right away is coordinate systems. You cannot in RoadEng talk to a GPS device unless you are in a what's called a Cartesian coordinate system. In general, you need to be in a coordinate system. So here I've got on my screen a map, and our office is in here somewhere. And when I turn on my GPS, I'm going to be located in here somewhere. But what's important to note is that I have set up this map, and it's based on a coordinate system. Just have a look at that. Many of you know about this stuff, but many don't. To be honest, we get a lot of calls from people who are still not quite familiar with coordinate systems. So this coordinate system that I'm using is UTM NAD 83 zone 10, and that is where my map is, and my map coordinates are in that system. And if I get it wrong, the GPS is not going to work. So there's lots of different coordinate systems all over the world. need to figure out what coordinate system you're working in and become more familiar with that. One thing that's very useful when working with coordinate systems is Google Earth. Google Earth will tell you right away if you're in the right coordinate system. So I've set my coordinate system up, and here's a linear feature in my file. All I have to do is export that to Google Earth, and it will pretty much tell me if I'm geographically in the right coordinate system. So it fires up here. Very useful tool. We use this all the time. Quickly diagnose if we're in the right place. And plus or minus a little bit of error there, you can see we are essentially geographically in the right place. So that whole step needs to be done before you connect any kind of GPS to RoadEng. Okay, let's switch over to something a little more interesting than this. Let's go to location. Same map, same coordinate system, but now I spent a little time yesterday afternoon. I designed a bike path from our office here, somewhere in here, down along a greenway towards Aroda. Yeah, it was a very quick design, so don't judge me on it. But there's a creek on one side, and I made a bike path down here. So what I want to do pretty quickly, I think, is to turn on the GPS. I've got a map. It's in the right coordinate system, so let's just turn on the GPS. And I do that through this connect. I have a GPS tab here, and I press the connect button, and it will start searching for available GPS devices. And because I don't have a real GPS connected to my computer, by the way, I'm in the office right now, not outside somewhere, so the signals are going to be very poor if I did have one connected. But it will look through these COM ports and look at the USB port, see if it can find a device. If it can't, it will default to this Windows location provider, which is a low-quality location service, very inaccurate. Some of the other options in here, if you're trying to connect to a GPS, you may want to use this test button. I click on that, and then I click on Start Reading. It's going to look at the port and see if it gets any feedback from the port. And you can see here that it's producing some fairly unfriendly looking sentences, but this really means that it's communicating with the GPS and it's working, and it's also showing me the lat long. So it's really a diagnostic tool. I'll just stop that and exit, and auto detect just repeats the process that it did on the way in here. So let's just connect with the GPS. Once you get your GPS initially connected, you won't have too much difficulty reconnecting with it. But initially, you may take a few, the usual thing where you have to configure. So you can see on my screen my position. I'm actually in the office, just in here, and here is my bike path, and here is the current station that I've got, and here's my profile. And in the section in the profile, I'm not showing the vertical elevation. I'll come back to that in a second. I'm just showing a band approximately where I am on those two locations. And if I walk down the bike path, obviously my GPS would follow my track along the bike path, and my profile window would update, and so would my cross section. So very quickly I could go down and have a look at the situation wherever I am. I'm sorry I'm not going to do that. It's actually pouring rain outside right now, but you'll have to trust me that if I walk down this path, that GPS would follow me. Some things to note. First off, accuracy. Your GPS has accuracy limitations. And if there's a, what's the word? It's like a status that's sent from the GPS device. It's called HDOP, and it really describes how accurate the reading is. And if the reading gets quite inaccurate, this little symbol here will change color. It'll change to an orange, showing you that you have a very poor signal for that device. I'm not sure that Windows Location Services really complies with that standard, but other proper GPSs do. The other thing that you can notice, if I zoom in a bit here, there's actually two circles around the GPS. And according to the GPS, this inner circle here, which I can change the color of, is the accuracy. That is the plus or minus accuracy, horizontal accuracy of that GPS signal. The outer circle is really just to locate the GPS on the map. If you were, if you were really zoomed out here, you could find it quickly. Accuracy, horizontal accuracy, usually pretty good. A mapping grade, maybe 1 to 3 meters for reasonable mapping grade. Vertically bad, and I would caution you to be really wary of what you get back vertically. I've seen huge differences. And the way to turn on the vertical position of the GPS is to go in here to Options and Show Vertical Positions. By default, it's off. And let's see, there you can see what this GPS is reporting as my vertical position. And because it's a location services, I don't even think it has a vertical position. It's completely meaningless. It's just set at 0. Real mapping grade, the GPS will return a better elevation, and you can use it for what it's worth. Be careful with it. Also, you have to understand that the map data that you're working with needs to be in the same datum as the GPS datum. So there may be some vertical differences between the two vertical datums. So all this stuff you got to worry about. I'm going to turn this off because it's not really adding any information here, and go back to just showing me horizontally where I am with respect to my designed section. Some of the things you can do, and these aren't necessarily new in this version, but obviously you can pop a label in here. It's not what I wanted to do. I want to put in a floating label right here and say something like rock outcrop. And we'll make this big so we can see it. So you can, as you're out with your GPS, with your design, you can mark it up and put labels at different places where you may have observed something, and of course you can put it right on the GPS. The other thing you can do is to actually alter your design. So you're out walking along your design, you find something that's not possible, unconstructible, so you actually can edit your design here, obviously. That might be difficult to do if it's really cold out or it's raining, but in some situations it is possible. I'm not sure. I think time will tell how much use that gets, but it is possible to in fact create a design out in the field with this type of software. So let me move on. By the way, this is, I think, going to be one of my shorter demos that I've done. That is GPS functionality in location. We have the same capability in terrain. If you were doing deflection lines or a site plan or something like that, you could track what you're doing. So you just take your RoadEng work out in the field. There you go. The other thing I wanted to show you was the survey capability. So again, same area that I have for the office here. I've artificially created a P-line traverse that runs near the office here. And what I can do is I could set the start station for this traverse. I could set it absolute, or I could come out here and let's turn on the GPS here as well. Just make sure. Yeah. Yep. Okay. So GPS, same thing. Just connect. Exactly the same stuff is in location. So there's my position. Now I can say, okay, I'm right here. Let's set this point to be an absolute coordinate. Let's use the compass rule to adjust the traverse so that my station out here. Actually, let's go back a little bit. That's a little closer. Oh, how about there? We'll move this point on the traverse to this absolute coordinate, and we'll adjust everything using the compass rule back to the first station, which is absolute. So to do that, I go into traverse. Sorry, I meant to go there. Traverse, adjust X, Y, Z, and adjust X, Y, Z. Oh, sorry, not adjust, set X, Y, Z, get set. And now I get this dialog box which lets me set the XY absolute and or the elevation. I definitely don't want to set the elevation. We've already established that it's kind of rubbish, but I will set the absolute coordinates, set them from the GPS. So when I do this, we should see the traverse be bent to that new position. It's telling me there's a deviation from the bearings and distances that went into the traverse of 4.3%. And there you see I moved my traverse so that point now lies right on the station, and I have an absolute coordinate at that station. The last thing I wanted to show you was the laser gun, but I don't think I can because I can't see it right now. So I think that's really all I had to say. Again, it's kind of a short seminar today. It's hard to do this stuff in the office, but it's certainly a lot nicer in the office than it is outside. But anyway, that's it. That's it for GBS RoadEng 8. And can you transcribe the question for me? I'm not seeing it here. Sorry, we got, if you could, questions. A read-only version of location. Okay, I'll read the question. Is there the potential to release a read-only version of location and train survey? The reason I'm asking is some of the operations spend more time behind machine. Some of the operators spend more time behind machine controls instead of a computer, and the simplified version or different solution for them might help. This question stems from the slide showing road designs in the current GPS location. The short answer to that long question is yes. It is possible to create a read-only version of location. Whether we have that available on our website for download, I don't think so. We used to, but it's like a demo version of RoadEng, which would just let you view the document, track things with your GPS, and not make any changes at all. probably along those lines and want to simplify it down. And I have to also add to that answer that this is our first foray into field usage for RoadEng, and I think that the product will evolve, making it easier, friendlier to use in the field. Our first steps have been just get RoadEng, add the functionality that provides GPS and gesturing and Lasergun interface. We'll work on simplifying the interface so that it's just easier to use in the field. So, long answer. The short answer is yes. It looks like we have a second question here. When you move the second station to your GPS positions, and it did shift the first station away from the actual start of the bike path, let me try and explain that. So I moved the bike path actually starts down south. This is the end of the bike path. I started it down further. So what I did was the bike path, I swung the bike path. I adjusted this point so that all the stations moved slightly. And I think I could, if I undo the adjustment, you'll see it swing back. So all of these coordinates here, let me just close this out. I'll scroll down so you can see where I was. I'll zoom this window. So yeah, the beginning of the bike path is actually, oh, here's an interesting thing it's doing. I've got auto scroll turned on in my GPS. So as I scroll, I'm fighting with the GPS because it wants to put me back. So I got to go back here and turn off that scrolling, and now I'm free to move around in my design. So yeah, there's the start of the path, P-line station 0, and here, up here at the end is the one that I adjusted. So if I remove that absolute, too many windows here. If I remove this absolute here, you'll see the traverse swing back. So I do that by going into traverse, set, get, and turn that off. Watch the plan window should swing back. There it did. So it's swung back. So I just pulled this station over onto that known point, and it used, like I say, the compass rule to adjust all that stuff. And this is, standard traversing methodology. Any other questions? No, looks like we're good. Well, I hope you learned something, and we'll be going forward with this. It's available in RoadEng 8. By the way, it is got the tag beta, and the reason we did that is that we'd like to have more people using it, more people testing, more different GPS devices to make sure that it's robust. From what the feedback we've had, it seems to work pretty good with most GPSs so far. That's it.